All right, welcome back. This is just Mr. Jones with Chapter 2.2, Graphing Equations. I first want to start off by reading the video questions. So question 1 will be, what is the most basic way to graph? Question 2, how do you find x and y intercepts? And please list 2 ways of doing that. Number 3 is check. I wrote an equation here. So check x equals y squared minus 1 algebraically for symmetry. Okay, so 2.1 is about graphing equations, and we will talk about all equations in chapter 2.2, and then after this, we will go specific into certain types of equations for the rest of the year. So the very first way that you should learn to graph, the very basic way of graphing, is by plotting points. So you will pick about 5 random points. When I say points, I mean x values. And you will plug them in into the equation to get your y values. Thus, you'll have an ordered pair, x, y. You will connect all these points, and you will connect them with a smooth line. So most often, the points I like to pick it's usually pretty consistent. I tend to pick points such as like -5, -1, 0, 1, and 5. Okay. Now these -5 and 5, those could change to -3 and 3 or -4 and 4. But I try to choose symmetric points. I always pick 0. Okay, and then after that, it's just the positives and the negatives. Okay, so if you'll hear me say this quite a bit, if you have no idea what the graph looks like, okay, I could give you some random equation. Let's say I give you absolute value of y equals 5x plus 3. You have no idea what that looks like. You should be picking values, okay? You can actually pick values for x or y. Okay? In this case, you may pick values for y. Plug them in and see what ordered pairs you get out. Okay? The only reason I say pick values for y in this case is because I can isolate this x. Okay, I could say subtract 3 divided by 5. So in this case, x equals absolute value of y minus 3 divided by 5. So I'm going to plug in my y values, find some ordered pairs, connect it, and get a general idea of what it looks like. Okay, because in fact, this one we will not talk about how to do that on a graphing calculator. Okay, so intercepts. Intercepts are where, so you have x and y intercepts. These are where it crosses that axis. So it's where graph crosses the x-axis. This is where graph crosses the y-axis. Okay, so that's one way you can find them, is just by looking at the graph, seeing, okay, my graph is here, it crosses the x-axis here and here, so those are the x-intercepts. Now, the more common way that we will find these is, if you notice here on these x-intercepts, I know the y value. Okay, the y value is got to be 0 because they don't go up or down any. So we're gonna find x when y is 0. Okay, so we'll plug 0 in my equation for y and figure out what x is. For your y-intercept, okay, I'm looking for y, whoops, but I know that x has to be 0. Okay, so we're looking for these points right here. Okay, and x, you don't go left or right any, so x has to be 0. and you're going to look for y. Okay, testing for symmetry. Now this gets a little bit tricky because we have 3 different types of symmetry, and your graph could have none of them, your graph could have some of them, or your graph could have all of them. Okay, so the first thing we want to look at is x-axis symmetry. Let's flip this up here. So x-axis symmetry obviously is symmetry about the x-axis. So if I have a graph here, let's say it looks like this. Okay, meaning if I fold it on the x-axis, it will, the bottom and the top will lie on top of each other. So how do I find algebraically if this has axis symmetry? So you will replace y with negative y, and nothing will change. And the equation will not change after you reduce. Okay, a lot of times I may talk about like x comma negative y. Okay, in fact this comes from the transformation, a reflection, which is why you replace negative y or y with negative y and nothing will change. And then we have y-axis symmetry. Okay, that is maybe something like this. Just a simple parabola shifted down. So in this case, you're going to replace x with negative x, and equation will be unchanged. Okay. Again, we could have a formula, x, y, negative x, y, from geometry. And then the last one is symmetry about the origin. Okay, so if we have a graph here, it could be something like that. Okay, symmetry about the origin. Okay, and it actually also has, origin has 180-degree rotation. So if I take this and swing it all the way down there, it lines up. But really what you're doing is you're taking this point, you're reflecting it through this point, and it lands in over here. So each one kind of looks like a rotation. So you will replace x and y with negative x and negative y, and nothing will change. Okay, so your equation will be the same as the original. Okay, so we'll have some of those to test out. So again, you can have your equation could have any one of these. It could have no symmetry, but it can also have all 3 symmetry as well. So we want to talk about some steps to graphing. Okay, if I give you some random equation, we got to figure out how do we go about graphing this. So the first thing we're going to do is find intercepts. Okay, you're going to find some x and y intercepts. Step 2 is you're going to test for symmetry. So find /test for symmetry. Okay, that will be very handy for this step 3 here. Step 3 you're going to find additional points. Okay. And we'll base what points we have on the symmetry and my y-intercepts. And this last step is to graph, but really you're graphing at each step. So you're going to find your x and y intercepts, you're going to graph it. You're going to test for symmetry, you're going to find additional points based on your graph. Okay. Okay, so for example, if we look at, if I find that, let's see, this and this and that, those are all points, those are all my intercepts. Now, I may want to test, and let's say that I just have a y-axis symmetry. Okay, so I know whatever happens on this side has to happen on this side. So I may want to find some more points here and maybe here. And then I can just reflect them over that axis. So let's say this point is here, and then this point is here. So then I'll reflect that the same distance over there and there. That actually looks like I have absolute value there. Okay, so we'll do some more of those in class time. Again, there are your video questions. Please make sure you're getting those done before class and not during class. Okay, and then there's your suggested problems. You could probably go ahead and get started. 73 and 77, those are some mistake problems. So the editors have worked out some problems, made mistakes, and they want you to catch them or find out where they are. And I've thrown in a true-false question that may or may not end up on a quiz or a test. Again, if you have any questions, please let me know. I'm here before and after school. As always, this is at THS, Mr. Jones, signing off.